Hi, welcome to the Shiko's Math Lab. So today's topic we want to talk about is how to find the volume of Frustum and by the slicing methods here. Okay, and let's take a look. How do we do this? All right. So the first is let's take a look. This is the Frustum we have here. Okay, so let's so this first term is a right circular cone with the height is h, and the lower base radius is r, and top base radius is lowercase r here. So I want to find the volumes of this first term. Okay, so like we talked before, the key for doing this is let's try to place the x-axis and the y-axis. Then we can see how are we going to do the cross sections here. Okay, so let's put the x-axis here. All right, so let's put the x-axis along the base. All right. And then let's put the y-axis right goes through the center here. Okay, so let's do this is my y-axis here. Okay, and so you imagine here, right? So think about if this first term continue go here, so then you will get a kind of like, you will get a right triangles here. So let's take a look at this one. Then after that, you can really translate this one to something like this, right? And so go like this way, okay? So this is your y-axis, this is your x-axis, right? Okay, so imagine that, right? Like I say, if this first one is a continue go, it touched the, the y-axis like that. And now for here, so this point here, this point is the R0, correct? Because this is the radius. Then the top here, I don't really know what is the point is touched to, right? So I will just say that this is 0, the uppercase h is the height. I don't know how, what is the height it go. Then the first term is right here, correct? And then this point here, all right? This point is lowercase r, so this point is the r, and because the height, so what is my h here, my y here, this is h, right? So this point's coordinates is r and h. Okay, so now in here, okay, so now I have this is r and h, r and the zeros here, right? So now in here, so this is the, kind of this is the first terms, like we cut it here, right? Okay, so now the first things here, like we talk about if I do a cross sections, right? So when I do the cross sections, if I cross section this way, so if I cross section this way, I'm use a different color. If I cross section this way, right? So in, if I cut like a perpendicular to the, like the y-axis, right? So if I cross section this way, I will get a circle, correct? All right, so that will be my AX or AY. So right now I'm cross sections according to the y-axis here. So now I want to find this radius, right? If I can find this radius, and then I will be able to find my area, and I will be able to the integration. Okay, so in here, okay, so now the key things here is I'm going to, so this is the line here, right? So this line, this green line, I'm going to find what this lines here. Okay, this green lines here, the slope of this green lines will be what the rise of runs, right? So you can say is the slopes here will be the, okay, so the slopes here you can say is the, okay, so the slope you can say It's the rise over runs here. So it's rise is h minus 0 and over r minus r, right? So or you can reverse it. So there's 0 minus h, it's fine. So this will be my slope for these lines, right? Okay, so now I have a slope, now I have a point, right? Now I can find the line. I use the slope and a point formula. I can find the lines here. So I will set y. So I will use so probably I will use this point because y is equal to 0. That's easier. So I will say y minus 0 is equal to the slope. So it's h, then the lowercase r minus uppercase r, and what is x minus what? X minus r, right? So it's x minus r. Okay, so I can say this is y equal to h r minus r, the x minus r. And since we are looking, right now I'm going to cross-section, perpendicular to the y-axis here, right? So I need to find this is really the x, right? So this radius is really the length of the axis here. So now I'm going to find the x here. So now here you can say the x here, you solve the, if you solve the equations here, then you can do this is the r minus uppercase r, the h times y is equal to the x minus r's, right? Okay, so this is x minus r, and then you can find that the x is equal to what? X is equal to the capital R plus the r minus uppercase R to the h. This is y here. So now I finally find the radius. I can find the area. So I will say ay, so it's a pi r square, right? So it's a pi r square. And see here, see this is my color coordination. So this is the new radius, right? So this is the radius of this cross-section against y. So now here, this is a pi r square, and r is what? Is r plus r minus r to the h and the y squares, right? So now I finally be able to, okay, so I finally be able to integrate that. And here I want to change the sign a little bit because so I want to, this is the r. Instead of minus plus, I want to minus here. I just want to switch this to r, capital R minus lowercase r, h, y. Okay, so I switch this to, I change the signs here. The reason why, because capital R is bigger, so I don't like to use a small number minus the bigger numbers here. Okay, so now my volume will be pretty easy, right? Just integrate with respect to y's here, right? So I move the pi outside, then the radius, this pink one is r minus little r to the h to the y square. And then let's take a look at what is the y value. Y value is from where to where? It's this blue areas, right? So it's from 0 to where? 0 to h. Now the remaining part will just be the integration. So this will just be the 0 to the h here, right? Now you just FOIL that. So this will be the r squared minus h, and this will be the 2r, then the r minus lowercase r, y, and then plus h, and r minus lowercase r, the square, y square, correct? And then the dy's here. So now this integration will be pretty straightforward, just a very tedious algebras, right? Now you can get this one will be the pi. So this will be the r squared y, correct? and then minus this will be y squared over 2, then cancel with these 2's here. So it will be h, then the r minus r, then this is the y squared, then plus 1/3. All right, so this is r minus r, h to the square, y third, right? Okay, so what is the boundaries here? 0 to h here, okay? So after you substitute, so this will be pi, so you substitute the h to y, so this will be the r square h minus, and then the h will cancel the h squares, right? So this will be r minus r, and the h, right? Then plus this will be the 1/3. Now this is h squared, y, so you substitute h is h cubed. So it will be capital R minus r the square, then you still have h outside, so it's h here. Okay, so now you can factor the h out. Okay, so you can factor the h out, and also I can factor I can take the 1/3 out. Okay, so when you take the 1/3 out, what happened to the first one? See here, the first one you will get what? You will get the 3r squared. So this is 1/3. So this will be 3r squared. You take the h out, minus 3r squared, and the minus is plus. So plus 3r, then plus, this is r squared minus lower r's, right? So this is r squared minus 2r lowercase r plus r squared. How? It's much better, right? So here, now you see, hey, this one can cancel. That's pretty good. So my final answer will be 1/3 pi h. Okay, now I have a what? I have a r squared. All right, so this is r squared, and here this is plus 3r minus 2r. So how many r here? I have r, okay? And then last one is plus r squared. It's pretty cool, right? So let's see our answers here, okay? So for this problem, the key things here is you need to know where to place your coordinate axis here. Okay, after that, then you recognize this triangle. So then you need to find the radius. So that's why you want to find the line and then find the x values here. Okay, that's it. I hope this help, if you have trouble to find the volume of the first term. And this way, I hope this video will help you to get it, okay? All right, nice talk to you, and let's go to the lab for our next problems, okay? Talk to you later. Bye-bye.